So welcome back to our conversation about proportions and proportionality. By this point, we now have a good understanding of whether a relationship that we're looking at is proportional or not. If it's two ratios or rates, we can simply do the cross products test to see if we get the same outcome. If the data is presented to us in ordered pairs or as a table, we can do an analysis of y over x every time to see if we get the same outcome, proportional. And likewise, if it's a graph, that's really the quickest and easiest of the test, where we can see if the graph is straight and going through the origin or is anticipated to go through the origin. So as a quick review, let's go back and determine if this is a proportional relationship or not. So if we do so, remember, it's testing out the ratio of y over x, of y over x. So I'm going to mark all my x values. Oops, I'm going to mark all my x values. I'm going to then go back and label what would be all my y values. And I'm going to quickly do my analysis of y over x. So there's y over x. So let's see. Y is 15, y is 20, y is 50, y is 45. I'm just doing this to keep the colors constant. Now my x is 15 to 18, negative 20, negative 24, 50 to 60, finally 45 to 54. So if we reduce all these down, we should quickly determine that we get a proportion, or we do get a proportional relationship, because let's see, I know 3 goes in, to both, that's 5 to 6. I know 4 goes in, that's 5 to 6. I know 10 goes in, that's 5 to 6. And I know 9 goes in, reduced down, that's 5 to 6. So we do indeed have a proportion. So now that we know, or now that we should be comfortable doing this analysis of y over x, we want to give it a name. That ratio that we established is called a constant of proportionality. So that ratio of y over x, this value that we came up with is called our constant of proportionality. And it gives us a missing piece so that we can write an equation very quickly for this data. So it represents, in terms of a variable in an equation, it's usually represented by the letter K or the letter A. And as we get into graphing further, we'll realize that it acts as the slope of the line. Now that may not mean much to you right now, but pretty soon it will, okay? Most importantly, once we know that K value, we can substitute that K value in this equation. So the equation for proportionality is represented as y equals some value of K times X. So if I know what K is, and from above, I determined that I was proportional, I know that K is 5 over 6, that's the missing piece that I need to write my equation. So to do so, I simply start out by y equals, again, it would be some missing K value times X. And once I know what that value is, I just go ahead and rewrite my equation. So y is equal to 5/6 times x. And we're done. That's the equation. Now, the purpose of that is what it does allow me to do now is once I start giving you values of x, I can multiply them by 5/6, and I can get a resulting value of y. And I could use that to test any of my ordered pairs. So for example, if I wanted to prove that when I substitute 60 in for x, in this proportional relationship that I will get 50 for y, well, it would be as simple as saying y equals 5/6, and we're saying that our x value is 60, which is like 60 over 1. And you notice when I cross cancel, I get a y value of 50 here, which proves that indeed that's the equation, because when the ordered pair up above said when x is 60, y is 50. So if I want to know other points that aren't part of the set of data, I could just substitute any value in for x, multiply it by 5/6, and get the y coordinate that goes along with it. So that's really what the value of determining what a proportional relationship is. It gives us an equation that allows us to make predictions of other data within the relationship. Okay? So as I move on, we're going to do the same thing. Now, we've already seen this table of data, and we've already seen this graph from a prior day of notes in a prior video. So we're going to just quickly fill in what we know. We know here's x, here's y. We have 3/2, 6/4, 9/6, 12/8, 15/10. And we knew all those values reduced down to 3/2. We now know that is our k value, because that was that relationship of y/x, which equals k. Okay, that's another way of thinking of it. So not only does y equals k/x, but k is equal to y/x. So if I want to write an equation, I simply have to say y is equal to whatever my k value is that I just calculated, 3/2, times x. And that's it. We're done. Okay, so we're going to learn how to take the data from ordered pair form or take the data from table form and write an equation. With the graph, it's going to be a little bit different, because I want to be able to interpret any point on the graph into an ordered pair. So I have 1, 2, 3 points I can work with. I'm going to take this point right here. I need to know that that point is plotted by way of traveling along the x-axis, 15, and then traveling up the y-axis. I want to be careful here because I'm counting by twos. Notice it's 4, skip 8, so that's really like 6, 8, 10, 12, 14, 16. That makes this mark 18. So my ordered pair is 15, 18. So I already know, don't forget, I already know this graph is proportional for two reasons. It's linear, and it passes through the origin. So any point that I set up for y/x, any point I set up for y/x is going to give us the same value. In this case, this point 18/15, when I reduce down by a value of a common factor of 3, I'm going to get 6/5. That's my k value. Don't forget, k is just equal to y/x. So one more time, that is the missing piece of our equation. I can replace in for k that value, 6/5, and say in general, when I multiply an x value by 6/5, I get a y value that goes along with it. Okay? So now we're beginning to learn how to write equations from the data, and that equation gives us predictability. That equation gives us the ability now to find other values of data other than what's provided to us that continue to form this proportional relationship. So that is our lesson on writing equations. The key is to set up your ratio of y/x, to solve for that k value, which is known as the constant of proportionality, and simply substitute that k value in the equation y/x and write the equation that will solve for any point within the proportional relationship. So make sure you have a clear understanding of that so that we are in a good position to practice it more when we meet next.